Okay, this is college trig 5th hour. Missing a few people today. We hope everybody's doing well. Mason and I are the only guys in here today. We're going to represent our gender well, right? Okay, very good. The law of sines. You've learned it. The law of sines requires that you have an angle and its opposite side. So the question comes up, what if you don't have an angle and its opposite side? What do you do then? Law of cosines. So if you had all sides and no angle, what on earth could you do? Because the law of sines doesn't apply. So we need to say something intelligent about a triangle and all of its sides. That being said from before, I'm very glad Miss Nelson stuck with it. Became a math teacher, don't you? She's a good math teacher. All right. So I'm going to create a height, but the idea is I want to say something intelligent about all three sides. So law of sines said sine of A over A is equal to sine of B over B. So that only involves two sides, doesn't it? So we want to say something intelligent that's going to involve all three sides in case we were given all three sides. And we can do that, but it's going to take a little trick here. Right now, any type of trigonometry that I use will be based around these right triangles. And so what I'm going to do is, in order to use this adjacent side, I'm going to call it x. If the entire length is c, and this length is x, then what would this length be here? C minus x. Very good. Now what I'm going to do is I'm going to use our Pythagorean theorem in order to write an expression that involves all the lengths but none of the angles. Okay? Pythagorean theorem would say that x squared plus h squared is equal to b squared. And that c minus x quantity squared plus h squared is equal to k squared. Would you agree that when I'm done, I want some type of equation that has a, b's, and c's, but no x's and no h's, right? I mean, because the law of sine, sine of a over a equals sine of b over b equals sine of c over c. We don't want x's and h's, okay? We want something we can use. So, I could get rid of the h squared, couldn't I? I mean, literally, I could just say h squared equals b squared minus x squared. Now I could substitute that in, and the h squared is gone, isn't it? Oh, plus. I got a negative x squared, don't I? When I square that, that's going to become positive x squared, isn't it? I'm going to get rid of that, aren't I? But we do come up with a problem. Let's square this. What do I get? C squared minus 2cx plus x squared plus b squared minus x squared equals a squared. Everybody see how I got the minus 2cx? And when I do this, as Hannah said, the x squareds go away. I'm now going to rewrite the formula to look like this. A squared equals b squared plus c squared minus 2cx. See that? It's actually kind of nice. This is like Pythagorean theorem, isn't it? it makes sense. You got a triangle. It's probably gonna look similar to Pythagorean theorem. A squared plus B squared equals C squared in 90-degree triangles. What if you don't have a 90-degree triangle? Well, it's gonna be very similar. You might just have something to adjust for it not being a 90-degree angle. The problem is we want to get rid of that x. So let's look at, it's interesting. They said the same thing third hour. No, not at all. Not at all. But she said divide, which is, I'm very happy you said something. But dividing isn't going to help us. I need to look at my original drawing. Hint, this is the law of cosines. Opposite over adjacent will give me tangent. Opposite over hypotenuse will give me sine. Adjacent over hypotenuse. All right. Yeah, okay, there we go. So adjacent over hypotenuse. So what angle am I going to use? A. Cosine of A is equal to what? X over B. See how I come up with the X? We don't want an X in our final formula, do we? So let's solve for X. What will we do to both sides? Multiply by. So B times the cosine of A is equal to X. Yes. So now, instead of X, I put in that piece I solved for, which was X is equal to B times the cosine of A. So I get A squared equals B squared plus C squared minus 2. We can write BC cosine of A. This C, what do you think? Now I have a formula that has no X's, that has no H's, and it says something intelligent. Notice, if I'm looking for side A, it requires that I know what angle. A. So the idea is if you have A and then the two adjacent sides, it will give you the opposite side. Okay? So, flip it over. The law of cosines can really be written 3 different ways. I'll start the first way. C squared is equal to A squared plus B squared, which looks like the Pythagorean theorem, doesn't it? But then you got to account for the fact that it's not a 90-degree angle. And you do that by going minus 2AB cosine of C. So, there's 3 ways to write it because you might not be trying to find side C. You might be trying to find side B. What do you think it is if it's B squared? A squared plus C squared. Cosine of B. Yep. A squared is B squared plus C squared minus 2BC cosine of A. I highly suggest that you look at this sheet at some point. Again, this is what you can use on the test. You can see these 3 formulas right here, okay? And that's what you're given. A squared, B squared, and C squared, those 3 that we wrote out, all right? These 3 sometimes people use if they want to solve for an angle. But today, again, we're going to focus on when you're not given an angle on its opposite side, which would be side angle side or side side side. All right. If you have an angle on its opposite side, here's the law of sines. If you don't, we're going to follow one of these. Okay. So 2 examples, then you can use your time to work. So solve the triangles given the following conditions. A, B, C. Solve my triangle. I'll write down the three given pieces. A is 26 degrees, B is 12, and C is 15. Whoop. 12, 15. There you go. So we want to find those other pieces. Again, if we want to use the law of sines, we would say the sine of 26 over A is equal to the sine of C over 15. But then we would have two unknowns, right? So which of the 6 scenarios do we have here? Which one is this? Yeah, this is a side angle side. And it says that there is one solution. We got to use the law of cosines. So we'll use the law of cosines. Go back here. Which side do you want to find? A. You have to find side A because it's the only one you don't have. But the whole idea is that once I have side A, then I have an angle in its opposite side. And once I have an angle in its opposite side, then I can use the law of sines. So that's the whole idea. We're trying to find a side opposite the angle. So I guess you could say we'll use the a squared formula. A squared is equal to, and we'll do b squared, so 12 squared, plus c squared, 15 squared, minus 2 times 12 times 15 times the cosine of 26. Yep, 2's already in the equation. So I don't really even think so much about what's A, B, and C. I just think of, okay, 12 squared, 15 squared, minus 2 times that times the cosine of that. Okay, just within those three that are gathered together. So all we got to do is make sure that we're working in degrees and not radians. I go to my calculator, and I just type it in. 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 26. I don't. There we go. Sometimes when people put this in there, they do 12 squared, enter, and then plus 15 squared, enter. They keep on pressing enter. Well, at the very end, they end up multiplying the whole thing by the cosine of 26. Is the 12 squared being multiplied by the cosine of 26? No, just that latter part is. So you got to be careful about order of operations here. I think you just type it all in, okay? And I press enter, and I get 45.43. Is that my side? No, that's a squared. So I got to square root the answer, and sure enough, we get 6.74. I do the law of sines. Sine of 26 over 6.74 equals the sine of c over 15. You get 0.9756, right? Pause. $15. Is that going to be my largest angle or my smallest angle? It's your largest angle, isn't it? So if I go second inverse of the answer, I get 77.31, right? But does sine know the difference between the acute angle or the obtuse angle? No. It doesn't. So that's why what we need to do is we need to think about our solution. So I allowed you to pick C here, so you'd understand that we get in a predicament. This is the most important part, most confusing part of the day. I want you to think about this right now. Okay? I'm going to erase this, and we're going to think about this situation that we have right now. You know that this side over here is 6.74. Follow my reasoning. Okay? If there is an obtuse angle, which angle would it be? C. We don't know if it's obtuse or acute. How about angle B? Do you know whether that's acute or obtuse? Why does it have to be acute? Because you can only have one, and if there is an obtuse one, it would be C, right? So when you set up the law of sines, after you find this one, you should start by solving for the smaller angle as opposed to the bigger one. Because sine doesn't tell you the difference between obtuse and acute, does it? It doesn't know the difference. You can take your calculator and you can type in sine of 120 and then sine of 60, and you get the same stinking result because it doesn't know the difference. The sine's positive in the first quadrant where they're acute, and it's positive in the second quadrant where they're obtuse. It doesn't know the difference. So that's why on your sheet, I tell you this. Side angle side. Use the law of cosines to solve for the missing side. When you go to use the law of sines, find one of the missing angles. Start with the angle opposite the shorter of the two given sides. So that's what we do. We go back to this piece and we say, okay, I want to find B or C. Which one do I find? Go to B. So sine of 26 divided by 6.74 equals the sine of B, not C, divided by 12. $53, 51.3. And I don't have to worry about that being obtuse, right? We know that that's acute. So let's see what happens now. How would I then find C? Minus everything from 180s. 180 minus 26 minus 51.30. I get 102.7. See that? We didn't come up with that the first time, did we? We would have just taken the acute angle and thought nothing of it. And here we would have been wrong. Okay? So that's why. Does that make sense? How you got to be careful with that? Okay. Law of cosines. Yep. Yep. Okay. Last one. A, B, and C. A, B, C. 10.5. 12.4. 9.1. Which of the six is this? Side, side, side scenario. That's what I got. Side, side, side. So, here's the... Did she even teach? She doesn't even teach, does she? Okay. Takes pictures. She is a scrapbook phenom. Just whoever she bribed, she probably paid them. She does. She giggles. All right. So, let's look at this. Now, I want to find a missing angle, correct? The question is, which one should I start with? Obviously, if I have side, 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 can I use the law of sines? No. Law of sines require two angles. Okay? Oh, gosh. Very impressive. Very impressive. All right. So, question is what to do. Where is cosine positive? Which quadrants? The first quadrant and the fourth, right? So it's positive in the first. Acute or obtuse in the first quadrant? Acute. Where's cosine negative? Second quadrant where it's obtuse. So does cosine understand the difference between acute and obtuse? It does. It knows the difference. If you take the cosine of any obtuse angle, say the cosine of 120, you get a negative value. It knows the difference. Whereas I go cosine of 60, I get positive 0.5. It knows the difference. So the deal is we can force out the obtuse angle right away. Which angle would be the obtuse one? C would be the obtuse one. So I want to solve for angle C because cosine can tell me right away whether it's acute or obtuse. It knows. So we set it up. C squared equals A squared plus B squared minus 2AB cosine of angle C. This time I'm going to fill in all the letters except for the angle. So I've got 12.4 squared equals 10.5 squared, 9.1 squared, 2 times 10.5, 9.1, cosine C. This is the last mistake that people make as they're working through this kind of stuff. I'm going to subtract the 10.5 squared over and the 9.1 squared over. But I can't combine this to the rest of that, can I? Because it's being multiplied by cosine of C. So that's what I'm going to do. I'm going to 12.4 squared minus 10.5 squared minus 9.1 squared. And so on my left-hand side, I'll get a negative 39.3. On the right-hand side, I have those other terms multiplied together. Negative 2 times 10.5 times 9.1. And I get a negative 191.1. Some people just, I don't know what it is about the law of cosines, but a lot of times people add that or subtract that. We want to divide that, right? Okay. We're going to divide both sides by negative 191.1. And so if I take negative 39.3 divided by negative 191.1, you see I get a positive 0.2057. You tell me, will the angle be acute or obtuse? Acute, because it's positive. If instead of a negative 39.3 was a positive 39.3, then you would come up with a negative 0.2057, you get an obtuse angle. So whether it's a negative or positive makes a big difference in your answer. So I'm going to cosine inverse that result, and I get 78.13. So we did not end up with an obtuse angle. We ended up with an acute angle. Why can I now just do the law of sines the rest of the way? Yeah. You know, some people, they just continue to use the law of cosines. There's not many of those people out there. But some people, they're like, okay, well, I know cosine will give me the right result, so I'm just going to use it then. But it doesn't matter. It doesn't matter at all. We know that these are both acute. That's the biggest angle. So law of sines will give us the correct result. No worries. So all I do is sine of angle A over 10.5 is equal to sine of what? 78.13 over 12.4. So do my math here, my calculation. I get that. I sine inverse that answer. I get 55.96. And then subtract from 180. And sure enough, 45.91. Just like we said, we knew we get two acute results. We've solved that triangle. So a lot of people, when they think of law of sines and cosines, all they think about is the formula. But there's a lot of geometric understanding behind this, isn't there? That type of decision making and flow chart is not only applicable to you right now as you work through this, that's often the way things work in the real world, you know, when you're making bigger decisions in your jobs. Okay, so knowing the right formula in the right situation is always very important. So your assignment, very straightforward. We've got whoop, that's calculus. You don't want to do that yet. Here you go. 6.5, page 518, numbers 9 through 18. That's what I gave you yesterday. I will not be here on Monday. Okay, got a meeting, and I will be back on Tuesday. But on Monday, I'm going to give to you an assignment where you solve 6 triangles, and they're all going to be different things. Sometimes you use the law of cosines. Sometimes you use the law of sines. Sometimes you get 2 solutions. Sometimes you get no solutions. And so you're going to have to work your way through that and figure that out, okay? So when I'm gone, that's going to be your assignment. Everybody got it? All right. Show me you got some smarts.